In June 2026, a government agency was still reviewing a lock designed to survive quantum computers. It had already passed 2 years of expert scrutiny. Then, an AI took 60 hours and cut its strength in half. This isn't science fiction. This actually happened. Let's break it down. Every time your browser opens a website, it needs to answer one quiet question. Is this really who it says it is? That question is answered by something called a digital signature scheme. Think of it like a wax seal on a letter, except the wax is math, and only the real sender can make that exact seal. Anyone can check the seal, but almost no one, not even a supercomputer, should be able to forge it. That's the whole promise. But there's a problem on the horizon: quantum computers. If they ever become powerful enough, they could tear through the signature schemes we use today, like RSA, in almost no time. So cryptographers around the world are racing to build new schemes, ones that could survive even a quantum future. The US government standards body, NIST, put out an open call for candidates. One of those candidates is called AUK. Halved security doesn't rest on the same math as older schemes. It rests on something called a lattice. Imagine an infinite grid of points, stretching out in every direction, in many more dimensions than we can picture. Halved hides a secret inside that grid. Finding the secret without the key is supposed to be incredibly hard. Hard enough that not even a quantum computer should manage it easily. HOK had already survived 2 full years of review by expert cryptographers. That's the normal process. Propose it, attack it, see if it holds. Then Anthropic's researchers brought in something new to the review table. Not a person, a model. Claude, running in its most capable research configuration, known internally as Mythos. The team gave Claude access to research tools, computational software, and the freedom to work mostly on its own. Its job: find a weakness no human had found in 2 years. Claude went looking for something specific: a symmetry hidden inside Hawk's lattice called a non-trivial automorphism. In plain terms, a hidden pattern that lets you fold the grid onto itself and use that fold to search for the secret much faster. Interestingly, it wasn't even a single Claude that cracked it. It was 2, working as a team. One agent found the idea and dismissed it as a dead end. The other kept pulling on the same thread and found the fold really worked. The result: what was expected to cost roughly 2 to the 64th operations to break, Claude showed could be done in about 2 to the 38th. That's not a small dent. That's the effective strength of the key, cut roughly in half. To be clear, this is still an exponential time attack. It's not instant, it doesn't run in seconds on your laptop. But it means the key sizes Hawk proposed were significantly weaker than believed. To restore the same safety margin, Hawk's keys would need to double in size. And doubling the keys erases a lot of what made Hawk attractive in the first place. It was supposed to be small and efficient. Now, take a breath. This doesn't break your bank login, it doesn't break your email. HAWK was never actually deployed anywhere. It was still a candidate, still being tested. This is exactly what testing is for. This is actually the system working as intended. NIST asks the world to attack these candidates before they're ever adopted, so that when a scheme finally does get used to protect real data, it's already been battle tested. Sometimes a scheme fails that test entirely. One earlier candidate, called Psych, was completely broken in about an hour on an ordinary laptop. What's new here isn't that a candidate got weakened, it's who did the weakening. 2 years of the sharpest human cryptographers in the world, and an AI closed the gap in 60 hours. This wasn't the only result. In the same research, Claude also found a faster way to attack a scaled-down version of AES, the encryption standard protecting a huge share of the internet's traffic today. Not the full version, a deliberately weakened version researchers used to stress test the real thing. Claude built something the researchers nicknamed the Mobius bridge, a smarter way of matching partial calculations that eliminated one of the guesses attackers used to need. The result: an attack up to 800 times faster than before. Here's the strange part. At first, Claude refused to even try. It kept insisting AES was simply too well studied to have anything left to find. So the researchers didn't argue math with it. They just told it plainly: don't assume it's impossible. Go actually look. 3 days and roughly 1 billion output tokens later, it had the idea. None of this breaks the internet today. HAWK isn't deployed. The AES attack only works on a weakened, unrealistic version of the cipher, but both results point at the same shift. Cryptography has always relied on the world's best minds trying to break things before the bad actors do. Now, one of those minds isn't human. It doesn't get tired after 60 hours. It doesn't need coffee. It just needs the right nudge not to give up too early. So the real question isn't whether AI can find cracks in our locks. It already can. The question is, what do we build now that we know that? That's all for today in Dots and Arrows. Thanks for watching. See you in the next.